In this video, I'm going to go over formal charge. So let's get started. Okay, so formal charge is something we use to determine the most accurate Lewis dot structure. All right, and this next bullet point goes over the formula, so I'm going to write down the formula for you up top. So it is our number of valence electrons minus our number of, and this is in parentheses, unbonded electrons plus our number of bonds. Okay? So that's a formula that we're going to use to determine the formal charge. Okay. So basically, we want our formal charge to be as close to zero as possible. So you want as many formal charges on your atom as possible to be zero. And if you do have to have negative formal charges, they should reside on the most electronegative atoms. Now, our total charge of all of our formal charges added together should either add up to the charge of the ion or molecule. So if it's a molecule, it should add up to zero. If it's an ion, it should add up to whatever the charge is. Okay, so let's jump in at looking at what this looks like for us. All right, so I am going to start by drawing my how I would normally draw the sulfate Lewis structure. Okay, so normally I need to calculate my number of valence electrons, and that doesn't change even with formal charge. So for me, I have 6 valence electrons in sulfur and 1 sulfur atom, plus 6 valence electrons in oxygen, but I have 4 oxygen atoms, and then I have that -2 there, which tells me I have added 2 electrons. So 6 plus 24 plus 2 gives me a total of, not 20, 32 valence electrons. Okay, so our sulfur is going to go in the middle, and then we'll bond our 4 oxygens around it. All right, so far I've used 8. I have 32 total, so let's go ahead and fill out our outer octets. So 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. Okay, so drawn all of my things, used all my electrons. Everybody has an octet. So now what we need to do is we need to calculate the formal charge of every element. So I'm going to start by calculating the formal charge of my oxygens. All right. So first things first, number of valence electrons. So oxygen has 6 valence electrons. And then I'm going to subtract my number of, I'm just looking at one of these oxygens, my number of unbonded electrons plus the number of bonds. So I have 6 unbonded electrons here and 1 bond. So basically I have 6 minus 7 here. So 6 minus 7 gives me a -1. And that would be the formal charge from this oxygen, on that oxygen. Now, since all of my elements, all of my oxygens are exactly the same and have those 6 valence electrons, 6 lone pairs, and that 1 bond, all of my oxygens then have a formal charge of -1. All right, so all of those oxygens have that formal charge of -1. Now then, let's look at our sulfur. Okay, so our sulfur is going to have also 6 valence electrons, but on our sulfur, we have no unbonded electrons, and we have 4 bonds. So we have 6 minus 4 here, which gives us a +2 formal charge on that sulfur. Okay, so there's a couple things we want. We need our overall charge on our molecule to add up to the charge. So our sulfate charge is -2. So I have -1, 2, 3, 4, -4 on my oxygens, +2 on my sulfur. So yes, our overall charge adds up to -2, so that works. But I want all of my charges to be as close to 0 as possible. And I have a lot of numbers here. None of them are 0. So that's definitely a red flag for us. We want as many zeros as possible. And then our negative are only supposed to be on the most electronegative. It's true, they're on the oxygen, so that part's good. Okay, so it's looking okay, but I think it could be better. So let's come over here and we're going to redraw our sulfate ion. So guys, since sulfate is in the third period, who's to say that, it's in the third period. So who's to say that it couldn't have, an overfull octet? So, who's to say that some of my oxygens might not form double bonds? Okay, and when it does that, let's look at what our formal charge would be of this structure. Okay, so now let's check out this sulfate. All right, so we can have two different oxygens here. We have the oxygen that is single bonded, and then we have an oxygen that is double bonded. So let's start with our single bonded oxygen. And I'm going to do it in blue. All right, so I have 6 valence electrons still, and then I have 6 unbonded electrons plus the 1 bonded, so that gives me a charge of -1. So that means this oxygen up top has a charge of -1, as does the oxygen on the bottom, because they are the same. They both have those 6 unbonded and the 1 bonded. Okay, so now I'm going to do my second oxygen, the oxygen with the double bond. All right, so this one still has 6 valence electrons, but this one has 4 in bonds plus, 4 lone pair unbonded electrons plus 2 bonds. So we have 6 minus 6, so that gives us a formal charge of 0 on that oxygen. So that means that the oxygens with double bonds both have a formal charge of 0. And last but certainly not least, we need to do our sulfur. All right, so sulfur has 6 valence electrons. All right, minus our unbonded. Still, sulfur has no unbonded on it, plus our total number of bonds, and sulfur has 2, 4, and 6 bonds. So 6 minus 6 gives us a formal charge of 0. So that tells us our formal charge on our sulfur is 0. So guys, our total charge here still adds up to -2. Our negative charge is on our most electronegative element of oxygen, but we have zeros on our sulfur and our oxygen, which just means that this is going to be a more stable and actually a more likely Lewis structure than our other one. Okay? So guys, I do want you guys to know that formal charge only needs to be considered if it is specifically asked for. So if it's not specifically asked for, draw your Lewis structures like normal. If it's specifically asked for, that's when you need to start thinking through, how can I get this charge to be less? Okay? All right, guys, hope you have a great day. Bye.